Welcome back to math. Here we are today on Number Systems Lesson 10, and you are with Mrs. Smith. And today we're going to talk about the coordinate plane like we did yesterday in the real world this time. So let's talk about our objectives first. Let's read this first one together. Starting right here. Ready? Go. I can use 0 and positive and negative numbers to represent quantities in real-world contexts. So just like in previous lessons when you talked about the vertical and horizontal number lines and you talked about positive and negative integers, we're going to use all of that today to put things on the coordinate grid, but it all has to do with real-world things. All right, let's read our next objective or our learning target right here. Ready? Go. I can plot, reflect, find the distance between ordered pairs, and create polygons on a coordinate plane. All right, kind of like what we did yesterday with plotting pairs and doing a polygon on there and finding the ordered pairs or finding the distance. We're going to talk a lot about distance today. So here we go. Here we have a coordinate plane. But I want to draw your attention to something very important. We didn't have this yesterday. We have a label here, and it's telling us that each box is 1 square mile. Now, let me tell you, sometimes on assessments or tests or something, they're going to try and trick you here. And down there, they might say 2 square miles. So each side would be 2, but we know in this picture that each side is 1 mile long. So over here, our first question says, what is the distance of the height of the square? Well, the height is how tall it is. So let's count how tall it is. 1, 2, 3, 4, 5. Now, yesterday we labeled it units because we weren't given a label, but today we were given a label of miles. So we know this is 5 miles. And what is the distance of the base of the square? Now, we know about squares, right? Squares have equal sides, but let's check it and prove it. 1, 2, 3, 4, 5. So here we have a square that is 5 miles by 5 miles. So far, pretty good, right? Just a review of yesterday. Now, what if I move that same square? See how we have this red square up here? What if I move it 1 space to the left? So can you see we moved it 1 space to the left? It's still the same square. Still the same, right? How many of you up here just said, oh, I'm at 0.5 over here, so I know it's 5 across. I'm at 5 up here, so I know it's 5 tall. Okay, that's a great way to look at it. Now, what if I moved it? Over here, I'm at 0.4, but is it really 4 across? No. So when you learned about absolute value, we really have our 4 on the right, plus the absolute value of -1, because distance, absolute value just means how far from 0 that number is, right? Distance can never be negative. I like to think of that as driving my car. And if I drove my car 1 mile backwards, not only am I a really great driver, I still went 1 mile. I can't go -1 mile, right? So I have to take that 1 over here on this side that I went and add it to the +4 on this side. And my distance that I went is still 5. Okay, so if we know that this square is the same as the last square, both sides or all 4 sides are 5 miles, right? Now, what is the area? Yesterday we talked about area is length times width for a quadrilateral. So we know we have 5 times 5, or the area, the total area it's taking up is 25, label, miles squared, or you could write square miles, either one, and that is the area. Now, if I counted all of the little squares in the middle of this shape, I would count 25 total squares. Now, let's look at this. Now we have a parallelogram, okay? A parallelogram is a quadrilateral, a 4-sided shape with 2 parallel sides, but the angles are not all right angles. Okay, so question number 1, what is the distance of the base of this parallelogram? Well, the base is usually the bottom or what the shape is sitting on. So find the base, and I'm going to start right here at positive 1. And let's count. 1, 2, 3, 4, 5. So that base is 5 feet. Remember to look down here. Sometimes it's down here, sometimes it's over here at our key. So the base is 5 feet, right? Could I have done, okay, I have -4 on this side, positive 1 on that side. The absolute value of -4 plus 1 equals 5. I could have done that. Okay. What is the distance of the height of the parallelogram? Height cannot be measured diagonally. When people are going to measure the Leaning Tower of Pisa, they don't measure from the base where you like enter into it and then across the Leaning Tower of Pisa. They actually will go up to the top of it and then drop something down to measure straight. So our height, we've got to measure straight. So I just like to pick a spot right here. And if you look, this is a straight line from the top to the bottom. And let's count how tall this is. 1, 2, 3, 4 feet tall. So what's the height of this? Or the distance of the height? 4 feet. Okay. Donuts. What is the diameter? And right now you're like, what does that mean? Read the parentheses. Distance across the whole circle. So I've got to go across the whole circle. Okay. And remember to find your key. Each box is 1 square inch. So what is the diameter or the distance across the circle? So for me, that means right here to right here, the distance across the donut. Now we're missing some numbers because the donut's covering it. But can you guess what number goes right here? -3. What number goes right here? +3. So on this half of the donut, I have 3. And this half of the donut, I have 3. So what's my total distance across? 6, label, inches. Now I know you're saying, Mrs. Smith, that's not inches. On my computer screen, that's more like centimeters. But because they told us inches, we just label it inches. It doesn't matter what they tell us, okay? Scale doesn't really apply to things like this when they give us those labels. Now review. I'm going to ask, well, I'll do one of these for you because it's a little different, and then I'll have you pause and do the other 3. So let me pull up my black, and I'm going to do this one. All right, remember, always start at the origin. Go to the left or right first, and it's +4, so I'm going to the right. 1, 2, 3, 4. And then go up or down, and this is positive, so I'm going to go up 2.5. So 1 whole, 2 whole, and a half. So here's where that first ordered pair would be. Go ahead and put that first ordered pair on your grid and pause. And then try on your own. All right, welcome back. Let's see. Let's put the next ordered pair on there. Let's see. I'm going to have to use pink because I can't find red right now. -6, 4.5. So go to the left 6 and up 4.5. We would be right in between 4 and 5. And that would be our second point. And then the next point. Come on. Here we go, green. +3.50. So I go +3.5 and up 0. I'm going to be right on my x-axis right here. Okay. And the last one, 2.5 positive, 2.5 positive. To the right, 2.5, up 2.5. So I'm going to be right in the middle. Whoop. Let me erase some of that. Maybe right in the middle of a box on this one. And that's okay. We don't always have to plot a point right on the corner of things. Sometimes points can show up in the middle. All right, how did you do? I hope you did great. If not, go ahead and pause, erase what you did, and try it again now that you know. All right, remember today's real goal is to work on real world problems. So, did you know Salt Lake City is built on a grid similar to a coordinate plane? Elizabeth is riding her bike from her home, located at point -3, 4, to the mall at point -3, -3. Plot the 2 points and find the distance between Elizabeth's home and the mall. Okay, so we have 2 steps. First, we've got to plot the 2 points. And the second thing is find the distance. Okay, so let's plot those 2 points first. Let's start by plotting -3, 4 for her home. -3 tells me go to the left 3 and up 1, 2, 3, 4. So here is her home. And the mall is at -3, -3. So to the left 3 and down 3. And here we have the mall. I'm going to put a $sign there because we spend lots of money at the mall. All right, so we've plotted those 2 ordered pairs. Now it says find the distance. So let's find how far between the 2. So she was going to ride her bike from her home to the mall. How far is she going to go? Now remember, each square represents a city block. So 1, 2, 3, 4, 5, 6, 7 city blocks. All right, let's do this one. Joey is going to the skateboard shop. He starts at point 1, 0. Let's put that point on there. 1, 0 to the right 1, up 0. We're going to put a point there. Let's see if this side works better. Put a point there. Okay. And he walks 3.5 blocks to the north. What are the coordinates of the skate shop? Okay. So he starts at 1, 0 right here. He walks 3.5 blocks to the north. Now, we've got to pretend that this is a compass. Never eat soggy waffles, right? So 3.5 north. So he's going to start here and go 3.5 to the north. So we go 1, 2, 3.5. And this is where the skate shop is. And it says, what are the coordinates? Remember, coordinates just means what's the ordered pair for the skate shop. So when I'm writing that ordered pair, remember how many did I go to the left or right? I went to the right 1, so +1. And then I went up, how many? 1, 2, 3.5. So 3.5 would be the coordinate. Sweet. Now we have Thomas. This is a real situation for me. Thomas is hanging a poster in his room. The area of the poster is shown by the red rectangle. So the red rectangle shows how big the poster is. He's placing a nail in the center of the blue line. Write the coordinates of where Thomas should put the nail. Remember, coordinates, just a fancy word for the ordered pair. So he wants to put the nail here on this blue line. So we've got to find the middle. So I'm going to go like this. 1 this way, 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 1 this way. Oh, they meet right here. Okay. So we learned that they meet right here. And we want the ordered pair. So how far right do I go? Now remember, I don't start on the poster. I start at the origin. Start at the origin, and I go 1, 2. So my x number is positive 2. 1, 2. My y number is positive 2. That is a terrible 2. Ooh. So he would want to place his nail at the ordered pair of 2, 2. Here we have town A is red, town B is blue. They're connected by a train, and there is a station right here at the yellow. The tracks are shown in gray. So we have train tracks that connect town A and town B, and there's a station right kind of in between them, right? Which town is closer to the train route, and how far away is each town? Well, I think it would be smarter to answer that question first, and then we can answer that question. So here we have town A, here we have town B. Let's see how far they are. Let's start at town A. Town A is 1, 2, woo. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks away. And town B, 1, 2, 3, 4, 5, 6, 7, 8 blocks away. So town A is 9 away. Town B is 8 away. So can you tell me which town is closer to the station? Town B is. Some of you could see that town A looked just a little bit farther away from the picture, but we proved that town A was farther. Okay. New topic. Let's talk about reflection, okay? So I want you to read this section as I read it. Follow along with me. Ready? You can read it out loud with me if you want, or you can just follow along. Ready? Go. A point can be reflected across either the x-axis or the y-axis. This graph shows a point in red, that's our original point, reflected across the x-axis. The reflected point is shown in blue. That's our copy. So our original is the red, and our copy is the blue. I know it kind of looks purple now. And we reflect it across the x-axis. If we were in my classroom, we would be holding our arm horizontally, like a subtraction sign saying x-axis. And then when we hold it vertically or straight up and down, we would say y-axis. X, Y, X, Y. Okay. The coordinates are as follows. Point red, the ordered pair, is 4, positive 5. Point B, the reflected part, is 4, negative 5. So, what do you notice about the coordinates or these ordered pairs right here? What do you notice? When I go across the x-axis, because I went across the x, right? X stays the same. Y becomes its opposite. So when I go across the x, x stays the same. Y becomes its opposite. Let's see if that's true. Now we have a red point is our starting point, and it's reflected across the y-axis to create the blue point. And here's the ordered pairs. The red, I started at 2, negative 3. The blue went from negative 2, negative 2, negative 3. So what do you notice about the coordinates? Are you noticing that the x is opposite and the y stays the same? So when I go across the y-axis, when I say y-axis, I want you to hold your arm straight up and down. When I go across the y-axis, y stays the same. X becomes its opposite. When I go across the x-axis, I want you to hold your arm flat like a subtraction symbol. When I go across the x-axis, x stays the same, y becomes its opposite. Okay. So I want you to try on this one. Reflect. That's just a fancy word. So it says reflect across the x-axis. So pretend, if you could, fold this graph along the blue line that I just highlighted and tell me where our new point is. Go ahead and pause and try it on your own. All right, welcome back. If I were to reflect this across the x-axis, I would be at -4, -4. That's where my image or my new point would be. And my ordered pair for the reflected point, -4, -4. And this point, did you notice it was -4, +4? So I went across the x. My x stays the same. My y becomes its opposite. All right, go ahead and try this one on your own. Click pause. Welcome back. I'm going across the y-axis this time. So I've got to, in my mind, imagine this flipping across that blue, and I would show up right here at +4, +4. So my new ordered pair, +4, +4. Remember, my old ordered pair is -4, +4. When I go across the y, my y stays the same. My x becomes its opposite. All right, try this next one on your own. Go ahead and click pause. Welcome back. All right, we are going to reflect across the y-axis again. That's what it says. So across the y-axis. So if I imagined this folded across that blue line, my new point would show up right here. And I would have the ordered pair of +1, -1. Ask yourselves, since I went across the y, did my y number stay the same and my x number become its opposite? All right, go ahead and pause. Try this one on your own. Welcome back. All right, we are going to reflect across the x-axis this time, and our new point should be up here at -5, +5. Now ask yourself, I went across the x. Did my x number stay the same for the 2 points? Yes. Did my y number become its opposite? All right, now look at this graph. Is point B point B is a reflection of point A across which axis? If I were to fold my graph in half along the axis, which one did I go across, x or y? Say it out loud, 1, 2, 3. I'm going to pretend that you said the y-axis, right? Picture this axis folding in half, and this would show up over here. Point A has the coordinate of 8, 0. What point do we get when we reflect point A across the x-axis? So if I reflect it across the x-axis, A, B, C, D, or E. This is going to sound crazy, but guess what happens? If I'm on the x-axis and I go across the x-axis, I stay at my spot. So I would be the same. Picture folding this line in half right here. Where is A going to show up? It's going to stay there, right? Now, if I folded it along this one, that's when it would become C because I would fold it across there. But I folded it across this one and it just stays the same. Weird. Okay, I'm going to do 2 problems from each of these, talk you through them, and then I'm going to let you try. So remember the trick. If I go across the x-axis, x stays the same. Y becomes its opposite. So -4, 5, the x would stay the same, -4. Y would become its opposite, -5. Okay, this one, x stays the same, -9. Y becomes its opposite. Oh, and in earlier lessons you learned the opposite of -3 is +3. Okay, I'll let you do the other two. Over here on this side, y-axis, my x number changes. Y stays the same this time. X becomes its opposite. So then this one right here, y stays the same. X becomes its opposite. Go ahead and try on your own. Welcome back. Over here, you should have 5 and -7 and 0 and -6. Over here, you should have -3, +3, and -4, +1. Fantastic work today. Great job. Go ahead and move on to the practice and then do your best on your exit ticket. Great work.